So problem of the day, and uh, there have been a good number of entries towards solving this problem. Some of them coming closer to the solution, some of them making some mistakes here and there, some of them hitting the bullseye. The problem was, we have these numbers A1, A2, A2, A3, A3, A4, AN, A1 adding up to 0. And each of these AJs, A1, A2, A3, A4, AN, are known to be either plus 1 or minus 1. We want to show that n must be divisible by 4 if this is the case. Now realize that if each of these AJs are either plus 1 or minus 1, then of these n entities, see, these are n entities, this is entity 1, this is entity 2, this is entity 3, this is entity n entities, right? Half of them must be plus 1, half of them must be minus 1, yes or no? That's the only way they could add up to 0. Because these products would either be plus 1 or minus 1, isn't it? These products, A1, A2, A2, A3, A3, A4, AN, A1 will either be plus 1 or minus 1, isn't it? And now, if they add up to 0, half of them must be plus 1, half of them must be minus 1. That means I can break n into 2 equal halves. Yes or no? That means n must be for sure even. N must be for sure even. N therefore can be written as some 2k, where k is an integer. Does it make sense to you? Right? Now, so k of these products, you know these products, there are 2k products in this sum, right? 1, 2, 3, n. K of them are plus 1, k of them are minus 1. Now, so k of them are plus 1 and k of them are minus 1. Yes or no? Now let me look at the product of all these entities. A1, A2 into A2, A3 into A3, A4 into AN, A1. Let me look at the product of all of them. Their sum is 0. Let me look at their product. Very clearly, since half of these entities are plus 1 and half are minus 1, then product of all the ones would be 1. 1 to the power k, let's say, just to be technical about it. And k of them are minus 1. So the product of those that are minus 1 would be minus 1 to power k, isn't it? So that means the product of all of this is minus 1 to power k. Product of all of this is minus 1 to power k. But let's check this out. This is like A1 into A1, A1 square. A2 into A2, A2 squared. A3 into A3, A3 squared. Similarly, A4 squared. Similarly, AN squared. All of this is minus 1 to power k. This product is minus 1 to power k. But do you realize that this is positive? A1 squared into A2 squared into A3 squared into A4 squared into AN squared is positive because they are squares of real numbers. They're positive. Therefore, minus 1 to power k, which is the right hand side, must be positive. And when can that happen? That can happen only when k is even. That means k must be even. That means k must be even. Now, if k is even, n must be divisible by 4 because n is 2k. And since k is even, n must be divisible by 4. Right? So this was the problem of the day. I hope you enjoyed the problem, enjoyed solving the problem. I hope it entertained you enough, and I hope those of you who sought the solution eventually enjoyed the solution as well, right? The next day you'll have yet another problem, not difficult, but itching, and we'll actually be exploring in character. Thank you very much. Bye-bye.